Hello everyone, today we are going to introduce the AC and DC system.
In 19th century, direct current was produced by Italian physicist Alessandro Volta's battery, Voltaic power, but at that time, the nature of how current flows was not understood. Direct current is the unidirectional flow of electric charge. A battery is a good example of a DC power supply. Direct current may flow in a conductor, such as a wire, but can also flow through semiconductors, insulators, or even through a vacuum as in electron or ion beams. The electric current flows in a constant direction. Direct current is used to charge batteries and as a power supply for electronic systems. Very large quantities of direct current power are used in production of aluminum and other electrochemical processes. It is also used for some railways, especially in urban areas. Alternating current is an electric current which periodically reverses direction, in contrast to direct current, which flows only in one direction. Hippolyte Pixii built the first alternator in 1835 in Paris, France, a device which utilized a magnet rotated by a hand crank to produce AC. Alternating current is the form in which electric power is delivered to businesses and residences. And it is the form of electrical energy that consumers typically use when they plumb kitchen appliances, televisions, fans, and electric lamps into a wall socket. However, there are some interesting history about the battle between DC and AC that we call War of the Currents was a series of events surrounding the introduction of competing electric power transmission system in the late 1880s and early 1890s. In the 1880s, industrialists and inventors wanted to find a way to use electricity to power street lights and to power homes as well, despite a war of currents between AC and DC power. At that period, alarm street lights around New York City are running on high voltage alternating current. After Thomas Edison and his company invented the large-scale, low-voltage direct current indoor incandescent lighting, they promote this new product into the market, fighting with the old version of the lighting system. Let's talk about the DC power system. Due to DC power systems has a large amount of energy lost, while at long-distance transmission, the electric power will transform to heat, causing the 1100 voltage power after transmit to the house decrease to 50 voltage. Lead to Thomas Edison have to build a lot of power plants every 1 mile to make sure the energy remain at 1100 voltage, so he made the power plant in everywhere. AC voltage changes polarity between positive and negative easily with a transformer, making it more efficient for transmitting power over long distance. This makes AC power more economical for power plants to carry over electrical wires to homes around the world. In 1886, the Edison system was faced with new competition, an alternating current system developed by George Westinghouse's company that used transformers to step down from a high voltage, so AC could be used for indoor lighting. Using high voltage allowed an AC system to transmit power over much longer distance from more efficient large central generating stations. As the use of AC spread rapidly, the Edison Electric Light Company claimed in early 1888 that high voltages used in an alternating current system were hazardous, and that the design was inferior to and infringed on the patents behind their direct current system. Finally, AC won out as the most viable power distribution method in the war of the currents. It is still the way we transmit power today. In fact, either AC or DC have their own advantages in different areas. Some examples of AC and DC in our daily life. Nowadays, actually, there are two types of fans on the market. They are AC and DC. Because of the difference of the motor's design, therefore, the wind power, energy conservation, and the function of a fan depends on AC or DC motor. Obviously, AC motor is cheaper because of the simple structure. Although the cost is cheaper, there is more power consumption. For example, the energy of input of AC is only received 20 to 30%. That means there is 70% energy lost during the transmission. Due to the simple AC structure, AC fan is lighter than DC. However, the speed adjustment of AC is not as much as DC. Normally, it is only 3 to 4 speed adjustment, so AC cannot adjust the very low speed like DC. On the other hand, DC motor brings the green living to us. Due to the high efficiency of input, 75 to 85% of input energy is received. Less energy loss, that means good for environment protection. And the minimum noise of DC is only 50 decibel because of the principle of electromagnetic effect. That makes less friction. Also, the energy consumption is only 1/3 of AC. Although there is almost no disadvantage of DC fan, the price is more expensive than AC fan.
It's the end of our sharing. Please like and share and subscribe our channel. Thank you.